Hi, math lovers. Welcome to notes number 41, lesson 2.2 on functions. We're going to start with the definition of a function. A function is a relation, okay? A relation is a set from set A to set B is a relation that assigns each element x in set A to exactly one element in set B. You can think of A and B, sets A and B, as your domain and range. Now, probably in Algebra 1, you talked about your function machine. A little machine there where you put the number in, your x or your domain, and it comes out as your range, your f of x or your y. Remember that Dr. Seuss book, Sneetches? All of the Sneetches wanted stars upon theirs, so they popped into their machine that put the star on their belly. They went in as a plain belly Sneetch and they came out as a star belly Sneetch. Famous function machine. Okay, I'm going to pull some problems from your textbook. So go to your book on page 194. 194, I'll try and zoom in here. See if I can do it without a glare. Okay, so a couple problems for us to talk about. Okay, first one, in number 7, is this a function? All right, so I look at all my x values. My x values each map to an individual y value. So I say, yeah, that's a function. Look at the difference, though, in number 8. I have -2 to 3, -1 to 3, and then -1 also to the number 4. So that's not going to be a function because -1 is going to be repeating its value, -1, 3, -1, 4. Okay? Down here, number 9, we've got the National League as our domain, and our range would be the individual teams. So let's see, National League to the Cubs, National League to the Pirates, National League to the Dodgers. I just said National League 3 times. That is definitely not a function. How about over here? I've got the domain as the year, and the range is the number of North Atlantic tropical storms and hurricanes. So in number 10, does every single year match up to just one number? No year has more than one number. So that's definitely a function. Okay? Number 11, all the way down here at the bottom, number 11. Look at your x values and your y values. Do any of your x values repeat? They do not. So therefore, it is a function. And number 12 over here on this side, let me see if I can get it for you. I've got 0, -4, 1, -2, 2, 0, 1, 2, 0, 4. Do you see how 0 gets mapped to -4 and 0 gets mapped to +4? Therefore, it is not a function. Okay, definitely not. Moving on to number 19. Okay, so in number 19, they're asking us, are these functions? I'm just going to pull them right out of your book. In 19, we look at this equation, x squared plus y squared equals 4. We just finished chapter 1. We know that's going to be circle. So think about your circle. Are any of your points going to map to more than one point? Sure they are. So if you think about that picture in number 19, right? You've got a circle. Your radius here is going to be 2. Think about this ordered pair and this ordered pair, all right? Say that this is 1. So you could have the ordered pair up here that's going to have a 1 and your y value. And down here, you're going to have a 1 and a corresponding y value. So that's definitely not going to be a function. So definitely not a function. Okay? Let's try something a little bit different. Let's talk about function notation. On number 44, they're giving us the function f of x is equal to the square root of x plus 8 and then an outside plus 2. So think about this problem. Oops, make sure you guys can all see it there. Sorry about that. Okay. So think about this function. F of x is saying, hey, you know what the name of the function is? It's called f. Really original. Okay. They're asking us to find f of -8. So everywhere I have an x, I'm going to put in a -8. So it's the square root of -8 plus 8 plus 2. Well, this is going to be 0 plus 2. That's 2. Easy peasy. They asked me to find f of 1. So everywhere I have an x in the original function, I'm going to put in a 1. The square root of 1 plus 8 plus 2. That's the square root of 9, which is 3. 3 plus 2, that gives me 5. And then they asked me to find f of, this is more fun, x minus 8. So everywhere in my original function that I had an unknown, everywhere that I had an x, I'm going to replace it with x minus 8. Okay? Just a substitution there. My parentheses don't do anything there for me, do they? So it's the square root of x minus 8 plus 8 plus 2, which is going to give me the square root of x plus 2. Okay, so f of x minus 8 is equal to the square root of x plus 2. Okay. The last kind of function I want to talk to you about is called a piecewise function. These are fun. So these are functions where part of the function has one set of rules and another part of the function has a different set of rules. I like to think about this as Halloween, okay? So little kids are going to come up to my house, and a little kid who's under the age of 3, I don't like to give them candy. I like to give them, I don't know, a little toy, all right? A little toy. So if you're under the age of 3, you're going to get a little toy. If you're over the age of 3, you're going to get a piece of candy. So you come to my house and you're 12. What am I going to give you? Candy. You come to my house and you're 1 year old. What am I going to give you? Yes, a little toy. Okay, so this is a piecewise function. I have different sets of rules depending on what my x value is, my domain. So in number 58, they're telling us here's the function. You're going to use the function 9 minus x squared if x is less than 3. And you're going to use the function x minus 3 if x is greater than or equal to 3. Now, kids have trouble with these piecewise functions because we're thinking about it backwards. Logically, we would say if x is less than 3, then you're going to use 9 minus x squared. If x is greater than or equal to 3, then you're going to use x minus 3. But we don't do that in math. We go the opposite direction. We say, hey, use this function if it follows that rule. All right. So here's the table that Ron gives us. We want to know what f of x is if we have 1, 2, 3, 4, and 5. Okay. So using that table, let's plug them in, our values in. I have the x value 1. 1 is less than 3. So I'm going to use this first equation, or excuse me, expression. 9 minus 1 squared, that's going to be 8. My second value is 2. 2 is less than 3. So I'm going to plug it into this first expression. 9 minus 2 squared. So it's 9 minus 4, which is 5. 3. Okay, 3 is not less than 3, but 3 is greater than or equal to 3. So I'm going to use this second one. So 3 minus 3 gives me 0. This one, 4. 4 is greater than or equal to 0. Or excuse me, greater than or equal to 3. So I have 4 minus 3, which is 1. And this one, number 5. Let's see, 5. 5 is greater than or equal to 3. So therefore, I use the second one, which is 2. Okay? Now you're probably wondering, because I know what you guys are thinking, what in the world does this graph look like, right? What does this piecewise function happen? How does that work? So if you're thinking about the graphs, you're going to take two parts of the graphs and you're going to put them together, right? So if you're thinking about the graph 9 minus x squared, okay, there's the graph of 9 minus x squared. It's a parabola that's going to go upside down, and our intersection is going to be up here at 9. So what I'm going to do is I'm going to think about the graph. F of x is equal to 9 minus x squared. Okay, here's a tiny little sketch of that graph. Okay, up here, this is 9, in case you were wondering. And then the second graph, f of x is equal to x minus 3. That is going to be a line, right? 1, 2, 3. My slope is rise 1 over 1. So my line is going to look like this, okay? 1, 2, okay, so 3. So we know that this point here is 3. So what we're going to do to make the graph of the piecewise function is I'm going to use this formula, right? I'm going to use this function for where x is less than 3. So this part of the graph, I'm taking this part. And over here, I'm going to use this graph where x is greater than 3, greater than or equal to 3. So I'm going to take this part of the graph and I'm going to stick them together. Now, it doesn't always look pretty, but it's exactly what you'd think it would look like. You know, just this part, if you could cut it out and stick it over here and cut this one out and paste it over there. So this would be the piecewise function. Right? We're going to use this function for where it's less than 3 and this part when it's greater than 3. Okay? Have fun on your problem set, everybody.